Hi, I'm Sean Gannon, and this is Minute Math. And today we're learning about percent change with increases and decreases. In this video, we're going to talk about some problems that have price increased by a percent, population decline, price fluctuation, revenue constraint, and lastly, a percent decrease and increase. And so, when you're ready, let's get started. A phone's price was increased by 30% to $390. What was the original price? Let's let X represent the original price. And so we want to make an equation now that involves this X with the information that's provided. So we have our original price, and we know that it was increased by 30%. So to show that percent, we would take the original price again. We don't know what it is yet. And we're multiplying that by 0.30, the 30% as a decimal. And this shows us that increased amount, this 30% of the original price. And they tell us that that equals $390. So now I want to solve for X. Well, 1X plus X times 0.30, or 0.3X, is a 1.3X, which is equal to 390. I want to solve for X, so I'm going to divide 1.3 to both sides of the equation. X is by itself, and 390 divided by 1.3 is a 300. And so the original price, right, of the phone's price, the original price was $300. A population dropped by 20% to 3,200 people. What was the original population? Let's let X represent the original population. And we want to make an equation that uses X with the information that's provided. So we have our original population here, and then they said it dropped by 20%. So I'm going to show what that value is. We don't know what the original population is yet, but we can represent it by X. So we take the original population subtracted by the amount that was dropped, which is X times 20% as a decimal, 0.20. And they tell us that it dropped to, so this is now the new population, dropped to 3,200. Okay? And now we can solve for X, which represents the original population. So X minus 0.2X is a 0.8X, and that's equal to 3,200. Divide both sides by 0.8, and X is by itself now. And X is equal to 3,200 divided by 0.8, which is 4,000. We have people here. And so the original population was 4,000 people. An item's price increased by 20%, then decreased by 10%. The original price was $200. What is the final price? So our original price was $200. Then they said it increased by 20%. So we're going to take that 200 and add a 20% increase on 200. That's 200 times 0.20, that 20% increase on the 200. This comes out to be 200 plus 200 times 0.2 is a 40, and that's a $240 right here. So after the increase, it was $240. Then it decreases by 10%. So we kind of do the same idea, but with this $240 as our new starting value. So we have $240 here, minus a 10% decrease on that. So minus 10% of 240, so 240 times 0.1 right here. 10, if you want to do 10%, kind of show that. And so we have 240 minus 240 times 0.1, which is 24, which comes out to be 240 minus 24 is a $216. And so our final price here, is $216. A store's revenue decreased by 5% to $950,000. What was the original revenue? Let's let the variable x equal the original revenue. And so I want to make an equation with the original revenue, x, with the information provided here. So our value, our original revenue, minus the 5% decrease on it, so 5% of our original revenue. So we can multiply that out, x times 0.05 as a decimal. This is showing that decrease of that 5% of the original revenue. And they tell us that's $950,000. And so now I can solve for x. Well, x minus x times 0.05 is a 0.95x. That's equal to $950,000 right here. Divide both sides by 0.95. And x is equal to 950,000 divided by 0.95 is 1 million. And so the original revenue here for this problem here, the store's revenue, was $1 million. A salary was reduced by 5% and then increased by 12%. The original salary was $50,000. What is the final salary? All right. We first want to take that $50,000, the original salary, and we're going to show how it's reduced by 5%, what it comes out to be. So we're going to take the $50,000 minus 5% of $50,000 to show that decrease. So that is 0.05 times that 50,000. And this comes out to be, well, 50,000 minus 0.05 times 50,000 is 2,500, which comes out to be a 47,500. So after the first decrease of 5%, the reduction, the salary is $47,500. Then it was increased by 12%. So now we have to take this 47,500 as our new starting point, 47,500. And we're increasing 12% of this. So 12% as a decimal is 0.12 times 47,500. So 12% of 47,500, we want to add that to 47,500. So we have 47,500 plus a 0.12 times a 47,500 is a 5,700. Then we add these two together and we get a 53,200. And so our final salary is $53,000 or $53,200. Let's recap what we have covered in this video. We first had a problem on price increased by a percent. Then we had a population decline problem. We then talked about price fluctuation. We had a revenue constraint problem. And lastly, we had a percent decrease and increase problem. I now leave you with this bonus problem. A group wants to raise exactly $500. If each donor contributes $20, how many donors are needed? Best of luck. I hope you learned something here on percent change with increases and decreases. And as always, thanks for watching.